All right. Well, hello, Honors Algebra 2. Welcome to week 2 of continued learning. This week we are going to be focusing on using our unit circle that we came up with last week. We're going to talk about how to solve trig equations, and then we'll talk about some of the applications of trigonometry. Now, in previous units, we'd always done graphing in addition to solving is kind of always how we finished up each unit. We will get to graphs of trig functions. However, those were kind of set apart as their own unit. So that's unit 10. That's why when we kind of started this after spring break, I told you really needed to make sure you got through units 9 and 10. Those are the two ones that are key for getting ready for next year. So as we start today, first thing I want to make sure that you've done, make sure that you've worked through the unit circle discovery. If you've not already, go back to Schoology, open up that activities folder under unit 9, and work through that unit circle discovery. I now also have an answer key for that discovery for you. I also have a video of me working through the entire discovery for you. In addition to that, I've got the unit circle practice game for you to play online. So if you do have internet at home and you're watching this video, then you can get to that as well. It's just a good place to practice filling in that unit circle. And I'll have some more details about the competition that we will do posted later on this week for you. So, we're going to start with just a basic investigation. We're going to be looking at coordinates at a few of the points along our unit circle. The first place that we're going to be looking at is going to be the coordinates at 30 degrees. And for convenience sake, I've just gone ahead and copied and pasted a unit circle at the bottom of today's notes. If you do not have your unit circle, make sure you grab that right now. So 30 degrees, we're first going to copy down the coordinates for that. So the coordinates at 30 degrees is radical 3 over 2. And positive 1 over 2. So I'm going to copy those down right here. And then we're going to find 3 trigonometric ratios at that value. The first thing we're going to find is sine, then we'll find cosine, then we'll find tangent. So let's start with sine of 30 degrees. So in looking for the sine of 30 degrees, what we want to think about is if we were to make a triangle, and it's already kind of there for you, you just have to drop down the edge on the right side there. First thing to remember is that the radius of this unit circle is 1, so your hypotenuse will always be 1. The x value, radical 3 over 2, would be this side length here, and positive 1 over 2 would be this side length right here. So if you're looking for the sine of 30 degrees, and remember sine, you'd be doing opposite over hypotenuse. So your opposite side is this 1/2, your hypotenuse is 1, and if you take 1/2 divided by 1, that's just 1/2. Next, we're going to find cosine of 30 degrees. So for cosine, instead of opposite over hypotenuse, we're now going to do adjacent over hypotenuse. So now we're looking at our adjacent side, which is radical 3 over 2, and our hypotenuse, which is 1. So if we take square root of 3 over 2 divided by 1, that's just square root of 3 over 2. You may already be noticing this is why the unit circle is kind of nice, is that if you think about it, your hypotenuse is always going to be a length of 1, which is going to make it really easy to find sine and cosine. Tangent, a little bit more difficult, but not too hard. Let's take a look at that now. So for tangent, we're going to be taking our opposite side divided by our adjacent side. So opposite side would be 1/2, adjacent side would be radical 3 over 2. I'm going to work that up here. We're going to take 1/2 divided by radical 3 over 2. When you're dividing fractions, remember that you're going to multiply by the reciprocal. So that's going to become 1/2 multiplied by 2 over radical 3. Then I can go ahead and simplify the 2's. So then my answer for right now is 1 over square root of 3. Only thing I have left to do is rationalize, so multiply by the square root of 3 over the square root of 3, and that becomes radical 3 over 3. Okay. So that's 30 degrees. Tell you what, let's do 45 degrees together, and then you can try 60 degrees on your own. So at 45 degrees, let's go ahead and take a look at that triangle next. I'm going to go ahead and erase my work from right here. Okay, so the next one we are looking at, 45 degrees. So we're looking at this triangle right here. And again, that's a right triangle. Remember, hypotenuse is still 1 because that's the radius. And this time, our side lengths are the exact same. So square root of 2 over 2 and square root of 2 over 2. So for sine, opposite over hypotenuse, you're taking square root of 2 over 2 divided by 1. And again, you're probably noticing that these are kind of nice to work with. Forgot to write the coordinates down. I'll do that real quick here. So that's just going to be square root of 2 over 2. Likewise, for cosine, we're going to be taking our adjacent side, which is square root of 2 over 2, divided by our hypotenuse, which is still 1. So that becomes square root of 2 over 2, divided by 1, which is just square root of 2 over 2. Lastly, for tangent of 45 degrees, we're going to take our opposite side divided by our adjacent side. So that's going to be square root of 2 over 2, divided by square root of 2 over 2. And some people could probably just go ahead and say that that's 1 right away. If you don't see how that becomes 1, really, it shouldn't be too hard to see. It's one fraction divided by that same fraction. But if you wanted to multiply by the reciprocal, then you could see it that way as well. So take square root of 2 over 2, multiply by 2 over square root of 2. 2's cancel, radicals 2's cancel, and you just get 1. So if you want to practice, this would be a good time to do that. Pause the video real quick, figure out how to go through 60 degrees, and then I will write down the answers in just a moment. Okay, so starting with coordinates at 60 degrees. You've got 1 over 2 as the x-coordinate, and then you've got square root of 3 over 2 as the y-coordinate. Sine of 60 degrees should have been square root of 3 over 2. Cosine of 60 degrees should have been 1 over 2. And for tangent of 60 degrees, you should have taken square root of 3 over 2 divided by 1 over 2, which becomes square root of 3 over 2 multiplied by 2 over 1. Again, the 2's cancel, but this time it actually works out kind of nicely. No need to rationalize. Your answer is just square root of 3. Okay. Now, obviously, there's a point to us going through this, and it's not that you're going to have to do this for every single coordinate on the unit circle. Instead, let's kind of look to see what we notice, starting with the sine of theta. So if you look at sine of 30 degrees, sine of 45 degrees, sine of 60 degrees, look to see kind of what they have in common. Well, 1/2 is the same as the y value, as is radical 2 over 2, as is radical 3 over 2. In other words, the sine of theta is the same as your y value. Likewise, for cosine of theta, so looking at cosine of theta across the board, square root of 3 over 2 is the same as your x value for 30 degrees, and square root of 2 over 2 is the same as the x value here and here. In other words, cosine of theta is the same as your x value. Now, tangent isn't one that you'll probably come across as easily. There's a couple different ways you can write tangent of theta. One way is that you can write it as y over x, so if you were thinking of that, nice job. But there's a second way. If you think about what we just said y was the same as sine, x is the same as cosine, so when we say y over x, then really tangent is the same as taking sine of theta divided by cosine of theta. And that's going to be a really important thing to remember, is that tangent of theta can be rewritten in a couple of different ways. What that means, though, is that now it's going to be a lot easier to evaluate certain values, especially if they're on our unit circle. Let me show you what I mean by that. So, it says use the unit circle to find the exact value of each trigonometric function, no decimals, meaning that I don't want you to put it in the calculator, so no calculator at all. Okay, so here's how this is going to work. We're going to use those properties that we just got done talking about to make these problems a lot easier. So when you're looking at cosine of 210 degrees, all you need to do is look at the x value for that angle. So coming down to our unit circle, 210 degrees has an x value of negative square root of 3 over 2. That would be your answer for number 1. For number 2, tangent of 240 degrees. Remember, tangent is the same as y divided by x. So if we go to 240 degrees, we've got negative radical 3 over 2 for y and negative 1 over 2 for x. Let's go ahead and work through that one real quick. You'll start to notice that tangent is about the only time that you actually have to show any work. All the other ones you can usually just write down some answers. So in simplifying this, negatives are going to cancel each other. You're going to end up multiplying by the reciprocal, so square root of 3 over 2, multiply by 2 over 1. Again, 2's cancel. Your answer is just square root of 3. All right. For number 3, we're looking at sine of 150 degrees. For sine, remember that that is your y value. So if I go to 150 degrees, the y value there is 1/2. There's my answer for number 3. So I'm going to skip over number 4. Cosine of 150 degrees, do the same thing as we did on number 3. Just instead of looking for your y value, look at your x value. Let's do some with radians. So tangent of 5 pi over 3. So we're going to go to 5 pi over 3, which is going to be in this fourth quadrant right here. For tangent, we're going to take y divided by x, so that's going to be negative radical 3 over 2 divided by 1 over 2. So negative radical 3 over 2 divided by 1 over 2, which really, if you think about it, is the same thing as number 2. It's just instead of having negative divided by a negative, you're having negative divided by a positive. So the answer should be the same, just with an opposite sign. So instead of positive radical 3, you've got negative radical 3. In fact, one thing I've had some students do in the past that might make tangent a little bit easier is they've kind of expanded their unit circle and they've just gone around the entire unit circle and written the tangent kind of off to the side of each of the parentheses. If you want to do that, that would probably make tangent go a little bit quicker. You'd have to go through and obviously do them all for the entire circle, but then you've done them just once and then you don't have to really do as much work for tangent. Okay, let's go to number 6. So cosine of 2 pi over 3. Cosine, remember, is just the x value. So 2 pi over 3, x value is negative 1/2, and there's your answer. Okay, let's skip around a little bit because I think a lot of these other ones are pretty straightforward. Let's take a look at number 10. Why not? So number 10, we've got cosine of negative 2 pi over 3. So again, you're looking at x value, negative 2 pi over 3. So you'll notice that your unit circle doesn't have 2 pi over 3. That doesn't necessarily mean that you can't use the unit circle to find this value. You just need to find an angle that's coterminal with it. And you can do that one of 2 ways. The way that I kind of prefer is for negative 2 pi over 3, I kind of think about if I was doing positive 2 pi over 3, that would be coming this direction. Negative 2 pi over 3 would just be the other direction, but you're going the same distance. In other words, negative 2 pi over 3 is the same as 4 pi over 3. And then you could look at your x value there as negative 1/2. And there's your answer. The other thing you can do is you can use what we talked about in section 9.2 when we talked about coterminal angles to find a coterminal angle with negative 2 pi over 3. In other words, if we add by 2 pi, and in this case 2 pi you would probably want to write as 6 pi over 3, then negative 2 pi over 3 plus 6 pi over 3 is 4 pi over 3, and there's that same angle that we were looking at just a moment ago. Let's do another one kind of like that. Let me get rid of some of the scratch work that I've been doing on this circle. Okay, let's take a look at number 12. So number 12, we're looking for y over x of negative 45 degrees. And again, you can do that a couple different ways. First way would be if we went around positive 45 degrees, we'd end up here. So just do that same distance, but in a negative direction, you're looking at 315 degrees. And again, you could also do that by finding a coterminal angle. Remember that for degrees, you're just adding by 360. Negative 45 plus 360 is equal to 315 degrees. And in either case, you're able to find your way to this angle. As for the actual value, take y divided by x. Y is negative square root of 2 over 2. X is positive square root of 2 over 2. Negative divided by a positive is a negative. And square root of 2 over 2 divided by square root of 2 over 2 is 1. So then the answer for number 12 is negative 1. Okay, before we go into this next section, I'm going to change a few of these problems around. On big ideas, there's going to be a few additional ratios that they're going to ask you to do that we have not talked about yet. And those ratios are the cosecant, the secant, and the cotangent. So let me talk with you guys about what those are, as well as their abbreviations and how to find those. So cosecant, the abbreviation for cosecant is CSC. I'm going to write that above it so it fits all on this one page. So CSC. And cosecant is the same as taking 1 divided by the sine. So it's the reciprocal of sine of theta. Secant is abbreviated SEC. It is the reciprocal of cosine. So it's 1 divided by the cosine of your angle. And then cotangent is probably a little bit more straightforward. Cotangent is abbreviated COT. It is the same as 1 divided by tangent of theta. In other words, the reciprocal of tangent. So what I want us to do on 13 through 18, and again, we're not going to work through all of these, I just want us to practice doing these reciprocal identities is what these are called. So if you're wondering, there is kind of a special name for these. These are the reciprocal identities. So make sure you've got these copied down somewhere. They aren't used as often, but they are useful. So we'll go through them here. So let's do this. On 13, instead of doing cosine of 135 degrees, let's take the reciprocal. So let's think about secant of 135 degrees. So for secant of 135 degrees, what you want to still be thinking of is you still want to be thinking of the x value. You really kind of want to find the cosine of 135 degrees first. So if you come over to your unit circle, here is 135 degrees. The x value is negative radical 2 over 2. So the only difference between cosine and secant is your reciprocal, so it's 1 over that. Or think about the reciprocal of negative square root of 2 over 2 would be negative 2 over the square root of 2. And then you'd have a little bit of rationalizing left to do here. If you multiply by square root of 2 and square root of 2, you end up with negative square root of 2 over 2 divided by 2. And then that simplifies to just be negative square root of negative square root of 2. Okay. For 15, let's change this from cosine to being cotangent. So this will be our chance to practice cotangent. So let's find cotangent of 60 degrees, which really what would be kind of nice to remember is that we've already found what the tangent of 60 degrees is. If you remember, that was part of our warm-up, was that we found tangent of 60 degrees was this square root of 3. So cotangent of 60 degrees is just 1 divided by that square root of 3. And then you just rationalize real quick, not too hard to do, and you end up with square root of 3 over 3. So really, these reciprocal identities, you're doing the same thing as you would for normal sine, cosine, and tangent, but then you're just taking the reciprocal. So let's do one more. Let's do number 17. This will give us a chance to practice the only one we haven't seen yet, which is cosecant. It also gives us a chance to practice with negative radian angles. So negative 2 pi over 3. I think we've already kind of discussed how to get to negative 2 pi over 3. We talked about that negative 2 pi over 3 up on number 10 was the same as 4 pi over 3. And then we found out that sine, let's take a look at it, the y value is negative radical 3 over 2. So then the cosecant, instead of being negative radical 3 over 2, you're going to take the reciprocal of that, which is negative 2 over square root of 3. And then we'll rationalize that the same as we have before. Multiply by square root of 3 over the square root of 3 becomes negative 2 square root of 3 over 3. And then there's your final answer. Okay, so guys, homework on this is up on Big Ideas for you. There's also a worksheet with some extra practice if you would like to work through that. And then don't forget, guys, that in addition to kind of working through our normal notes and homework, to keep practicing memorizing that unit circle. Because remember, that's going to be one of those things that the better you know your unit circle, the better off you're going to be, not only this year, but next year as well. That being said, guys, have a good rest of your time, and I will talk to you next time.